everyone, or whenever time you look at it, afternoon, evening for you. This is KP the Math G, getting ready to do another AP Calculus AB problem. Going from the 2025 free response question number 5. It says particle J given by B at J at T. Now there is an X at H at T. We don't have to worry about that one, the function of H. We're just worried about the function of J. So it's given by this velocity equation, V at J at T equal to 2T times T squared minus 1 raised to the third, is at position x equals 7 at time t equals 0. Find the position of the particle at time t equals 2. So on the x-axis, this thing is sitting at, the position of this particle J is at x equals 7 at time t equals 0. Now it's already there. It's at that point. It doesn't start at 0, it's starting at 7. It's kind of like if you realize, or you may think you're faster than someone else, and you probably know you are, and you give them a head start. You're at 0 at time t equals 0. They're sitting at 7 at time 7 yards away, 7 feet away, at time t equals 7. And that's the position that that person is in. Well, this position of this particle, I always like to think of a particle being something like a marble or something like that. I don't know how you view it, but that's kind of the way I see it. It doesn't matter what the particle is. It's a particle. Okay. Find the position. Okay, so now what's this equation written in? Velocity. So remember, keep in mind that when we are changing, we want to find the position. So the position would probably be something like this. So you remember, if we took, when we did our last problem, part C, I think it is, we had to find the acceleration. And to do that, what did we do to find the acceleration? You're right, we took the derivative. Okay? We took the derivative to find acceleration. So if we want to find, so we have what you call position, the position equation. Okay? We have the velocity equation. Alright, and we have the acceleration equation. Now we're at this point right here. So if we want to go forward, we take the derivative of the position and we get the velocity. If we take the derivative of the velocity, we get acceleration. Okay. However, though, let's erase this. If we want to work backwards, what do? So in other words, if I'm here at acceleration, if I integrate from A to B, whatever. Alright, acceleration, I'm just kind of, okay, we're just going to kind of, I know dx and all that stuff, but anyway, we get velocity, don't we? Okay. If we integrate from A to B, velocity, we get position. And so that's where we're at right here. We want the position equation. We want that word position we want that already. So, okay. So you have to learn, probably part of your struggle, if you have a struggle at all, is do I take the derivative or do I take the definite integral? In this case, we're going to take the definite integral. And here's how we're going to do this. Let's get a different color. Now, my wife is telling an animal, probably one of the cats, to go somewhere. We're getting ready to go in a few minutes to the Y. I got to work out a little bit on these arms, you know, and legs too, but basically right now, probably my arms. I'm looking forward to it. Alright, anyway, you start at 7, so leave that alone. You're already there, starting there. Now you're going to integrate. Now, from what to what? Well, we know that it's starting at 7 at time t equals 0. We want to know the position of the particle at time t equals 2. So that's one thing that we need to get. Those limits of integration. Okay? So we have that. Now what do we have? Velocity. Alright, so that is 2t times t squared minus 1 cubed dt. Sometimes you can get away without putting the dt there. I like doing it. You know, you're on the safe side anyway. But if you show this, I think you're going to get a point. If you can at least show this. Okay. But now they're asking you to integrate. Now, how do we do that? Well, one thing I noticed is that this exponent is 1 greater than this one. Never mind what this 3 is. Forget that. I used to let that bother me tremendously. But you don't have to multiply this 3 times and then multiply this into all that and then try to integrate. You can, but boy, it takes a long time to do that. So here's what we're going to do. A different color. Well, let me get over here where I can work. I should have scooted this over a little bit, but that's alright. Okay, so let u be equal to the exponent that's 1 bigger. If we had something else, like if it's 2 bigger, we're in a little bit of trouble. But let's let u be equal to t squared minus 1. Again, don't let it be cubed. You don't do this. No, just this. Just this. Alright? Just that. Now watch what du is. Du is the derivative of this. The derivative of the left side is just du. The derivative of the right side is 2t minus 0, which is just 2t dt, right? We have 2t dt, don't we? Alright, so really, if we wanted to rewrite this, we got 7 plus from 0 to 2. Alright, t squared minus 1, 2t dt. I'm just moving this over here beside the dt, right? Just kind of doing that. Alright. Now, let's see the substitution. Let's do it again. That's equal to 7 plus. Alright. Now, u du. There's du's, 2t dt. Some people want to say, had this just been a t right here instead of a 2t, then you would have to multiply by half or divide by 2, and you have a 1/2 du is t dt. you got a 2t dt, so I recognize you already have that, so you can just do du, right? Now, one thing that you can do before you integrate, let's put that on the other side, 7 plus, okay, let's do the whole thing over here. Let me look. 7 plus, okay, alright, let's see, 7 plus, okay, I got it. So V J, that T, originally was 2T times T minus 1 raised to the third. And what we did was we let, so we had 7 already, that's where that's at. Don't put an integrating on the 7. Just integrate here. Just integrate there. And that's going to be part of your answer, but let's go ahead and put that right there like that. Now, I think what we had is we said let u be equal to t squared, yeah, t squared minus 1, then du is equal to 2t dt. Alright, oh, okay. So what we have here is u du. Okay, and actually what we have here is, before that we had t squared, oh, I like to look a little bit better than that, t squared minus 1 cubed 2t dt. Alright, get the blue back out again. I think blue shows up a little better than green does, so let's go with that. 7 plus. Now, I'm going to leave off these limits of integration. Matter of fact, I'll need a little more space down here. I'm going to fill in these boxes. Alright, I'm going to show you something. Alright, so look what you let u be. T squared minus 1. Put your 2 in here. 2 squared minus 1 is 4 minus 1, which is 3. Now, instead of that being a 2, put your 3 right here. Okay. Let's watch it. Now, t squared minus 1 again. It's going to go to the lower, so we have 0 minus 1. 0 squared minus 1 is negative 1. So put negative 1 here. Now you said this is u cubed, right? U cubed du. There's your cube coming in right there. This is u, and all of this is du, right? Okay, I'm not putting it over u, I'm just saying that is u. All of this is u, okay? All of that is u. All of this is du. Okay. Alright. Now we can just use u instead of t, and we're going to get the same answer. Okay, so 7 plus. Now we're going from negative 1 to 3. Now, again, u to the 4th divided by 4, right? Isn't that what it is? Yeah? Okay, there we go. So here we go. 7 plus. Alright, 3 to the 4th over 4. Minus negative 1 to the 4th over 4. Be careful that you put that in parentheses. Like that. Alright. This is 7 plus. Let's go up here. So 7 plus 3 to the 4th is 81. 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. So watch this, 81 over 4 minus sign. Now negative 1 to any power, to an even power, is 1, positive 1. Negative 1 times negative 1 times negative 1 times negative 1. 4 negatives make a positive, so minus 1 over 4. Nice, because I know what 81 minus 1 is, and that's equal to, and that equal to 7 plus 81 minus 1 is 80 over 4. Oh, I can reduce that. So that's going to be equal to 7 plus, alright, 220, so 27. There it is. Alright, so there it is right there. That's the position. Well, actually, yeah, that's the position. Okay, after 2 at t equals 2. What are we talking about? This could have been in inches, feet, meters, miles, centimeters. So if this was in centimeters, this is going to be in centimeters. But they didn't give you any units, so you don't have to put any units down. So the answer is 27. Okay. Alright, there you go. Right there. This, I hope, didn't confuse you. This is just an easier way. You don't have to go back to the t squared minus 1. So that is alright right there. I don't have time. If I had time, I would go back probably and discuss how to do this with the 0 and the 2. If that does confuse you and give you a little trouble, I might go back the next time and show that both ways. Time just will not allow me to, because we're getting ready to leave and go to the Y and do a little exercises. I need to exercise. I need to get this off of me right here. A little embarrassed with that. I've never weighed this much before, so I'm going to start exercising and trying to get my, of course I can still do some things. I can lift weights, I can do leg weights, I can jog a little bit, I can even jog outside. I just can't jog very fast, but I can jog outside. I'm 65 and I just need to keep my strength up. I need to keep my stamina up just a little bit. Not trying to impress anybody really per se, but I just want to stay fit and look, you know, a little decent. And so I'm going to work on that. So anyway, this is going to make the 174th, I think, video. If it's not 174, it's 175, but I believe it's the 174th video. And so I've been, all of them are calculus based, by the way. And I enjoy doing this. I used to be shell shocked to see a problem like this. But what you know, after doing this so many times, and we used to, teachers would work with other teachers as well, I learned this. It's not that hard, and believe me, U is this. Plug these into U right there. 2 squared is 4, minus 1 is 3. 0 squared is 0, minus 1 is -1. And that way you can just keep the U throughout. Alright. So anyway, that's how that works. Remember also that when you have a velocity, had this been acceleration, you would have had to integrate twice. Yeah. But since it's in velocity, you just have to integrate just one time. And this was turned out to be a product. I think, I can't remember the product rule. I can't remember what that was, but yeah, this turned out to be really nice. Again, when you let U be anything, just let it be this part here. and du is the rest of this. And there it is. Okay, ladies and gentlemen, that is this is all we have here for now. I love these types of problems now. Just keep in mind there is a word that says position. You see that, you already see this, that just gives it away right there. Okay, do not put an integration in front of this. Put your 7 already out there, plus. Had it been -7, you would have said -7 right here, plus. Always plus here, whatever. Okay, and if it's at 0, which time t is usually that, had this been, say, 1, you would have went from 1 to 2. Okay, like that. Anyway, from 0 to 2. So this is telling us what the distance is. So again, this would be, if this were saying centimeters per second, now this answer is in centimeters. Okay. Alright, I hope that's helped you. I believe, that's about what I can do to help you get where you need to go with this. Some of you already know it, maybe. You probably just need a little refreshing on that. But at any rate, whether you struggle with this or not, this is really good to have and really good to know. Alright, I'm going to sign off with my signature clap in a moment. KP the Math G getting ready to sign off. Make sure if you have not hit that subscribe button, please do so. If you like to make a comment, please do so. If you would like to hit that like button, I always smile when I do that. I love this like button, but if you don't do any of those, get this. Okay, I have no fancy equipment other than this whiteboard, but I'm blessed to have the whiteboard. KP the Math G getting ready to sign off. Ladies and gentlemen, have a great day.